What's going on, guys? My name is Amos and I'm back again with another video. So in this video, let's write a few utility functions that we're going to need later on to process the automata. So the very first function that I want to write is a function that is going to find a state if we provide its representation, right, or its name. So if we provide the name of the state, then it's going to give us back the it's going to return a pointer to that particular state. Now, we're going to make the assumption, and we're going to make sure, it's not really an assumption, we're just going to make sure that every state has a unique name in our structure, because it wouldn't make sense to have two states that have the same name. Okay, so we'll just have a unique name for every state. So that is why this is going to work. This logic is going to work, and that is why it makes sense to have to return a pointer, or to return a pointer to the very first occurrence. Okay, to put ourselves in, to put ourselves under that general umbrella. Now we need to return a pointer to a state, right? So we're just going to say a state t, like so. This is what we're going to return, and we're going to call the function, or we're going to expose this function. It's a utility for me. We're going to expose this function. So we're going to say auton find state by, and I think it's erpr, and then we take in a pointer to the automaton. So we'll say a automaton, like so, taking a pointer. Then we're going to say automaton, and then we take in the name, we take in the name of the state. All right, we take in the name of the state. Now the very first thing that we have to do here is to assert that automaton is not null, and we also want to assert that repr is not null, like so. Okay, so we're now going to say, let's say a state t, like so. State is going to be equal to null, right? And at the very end, let's make sure that we return state, like so, because we have to return the state. And now that we have this, we need to return a state. So we're going to loop through all the states in the automaton. So we'll loop through all the states. So I'm going to say size t, I is equal to 0, I is equal to 0, like so, 0, and then I less than, we're going to go automaton, and then num states, like so, automaton num states, and then I plus plus, like so. Okay, we loop through all the states, and then we check if we compare string cmp, like so. We're going to compare the automaton, then we're going to go states, and then we have to say we have to compare the representation of every state in our array of states. We need to compare the representation with the representation that we receive as as argument. Okay, so if this is equal to 0, it means they're equal. If this is equal to 0, then what we have to do here is we're going to say state is going to be equal to automaton, and then states, and then states, I think e, like so, and then we close that with a semicolon, and that is going to be it for this particular function. So we loop through all the states, and then we compare the string representation, or the name of the state, to the name that we receive here, and if those are equal, then we say state is going to be equal to states, and then I, like so, and then we return the states here at the very end. So this is our first function. The next function I want to write is I think it's going to depend on okay, it's going to depend on something else. Let's first of all write a simple function to find the number of states. So we'll just say st, and then we'll say auton num states, like so. I think okay, number of outgoing states. So this is the number of outgoing states, right? So we're going to say auton num, we're going to say out states, right? Out states, and then this is going to receive, this is going to return an int because we're looking for the number of outgoing states, right? Which is going to be an int. And then we're going to receive as argument, some state, okay? We're going to receive as argument some state. So we're going to say state here. That's what we're going to receive as argument, okay? And we don't want to modify this, so we just say const like so to protect that. And then yeah, so we assert that what they've given us is not null. So we assert state like so. We want to return the number of outgoing states. And because we have an attribute, so we're going to say, well, is this even necessary? Well, because we already have some attribute on the structure, on the state structure. Do we really need to do this? Okay, I'll just write it for now. But I think since we already have an attribute, we can just reference that particular attribute. Okay, but it's not a problem. So let's just return. We just have to say state, and then we just have to go num, I think. What is it called again? It's out transitions. So probably have to like use the same name here. So we have to return states, state out transitions, and then auto num out, and I'm going to say transitions like so, and that should give us the number of outgoing transitions. And we're going to need this, I think, in some other function. Now the other function that I want to write as our utility, as our next utility function, is the function that is going to return the state that has the most number of that has the greatest number of outgoing transitions. Okay, the state that has the greatest number of outgoing transitions. And we want to return a pointer to that state that has the greatest number of outgoing transitions. So we're going to say auton state, and I think with max transitions. I think transitions like so. That's what the function is going to be called. We want to return um, the state with the maximum number of transitions. So we're going to take in, as argument, we're going to receive automaton. So we're going to say a automaton pointer to that, and we're going to say automaton like so. And so we assert that we do not receive something that is null. We assert automaton like so. That works. Okay, so we want to return the state with the maximum number of transitions. Okay, after setting, we're going to say, I'm just going to say state state t like so is going to say, I'm going to say state like so. It's going to be no. Okay, it's going to be no like so. It's going to be no, and then here we're going to return state like so, and then in between we want to write our logic for finding the state with the maximum number of transitions. So I'm going to first of all say int max transitions. I'm going to set it equal to -1, right? Or to any negative number, really. It's going to work. So I'm going to set it equal to -1. The number of int max transitions is going to be -1, right? So let's loop through all the states. So we're going to say size t, I is equal to 0, and then I is less than automaton like so, and num states like so, and then plus plus I or I plus plus, right? So as we loop through, and then let me just grab Let me just grab. Okay, let's go ahead and first of all get the number of transitions, the number of outgoing transitions. Uh, and I think it makes sense that we call, this variable max out transitions, not just max transitions, because we're talking about outgoing transitions. We can also have incoming transitions, but now we're talking about outgoing transitions. So I think what I need to do here is, let's first of all grab the number of outgoing transitions of the current state. Okay, so I'm just going to say current count is going to be equal to, we already have a function that gives us, I think, the number of outgoing transitions. We already have a function, right? I think it's auton num, yeah, number of outgoing transitions. And I think here we should provide, we're going to say automaton, we should provide, so we're going to go states and then I, because it expects it expects a pointer to the state, and then we provide a pointer to the current state that we are on. So we close that. So this is going to give us the current count, or the current number of transitions. Then as long as this current count is strictly bigger than the maximum number of outgoing transitions, this is going to work for the very first. That's why I had to initialize max out transitions to -1, because I want, it to work in the very first iterations, in the very first what's this, in the very first iteration. Okay, because if we have a state that has 0, the minimum here is 0 outgoing transitions. We cannot have a negative number of outgoing transitions. It doesn't make sense, right? So that is why I had to set it, or initialize it, to -1, so that I keep modifying the current the max out transitions. Okay, so that's the idea. So as long as the current count is strictly bigger than the max out transitions, I want to update max out transitions. Max out transitions is going to be equal to, max out transitions is going to be equal to the current count, right? As long as current count is strictly bigger than the max out transitions, then I want to update max out transitions to match current count. Okay, and then I want to say state is going to point to the current state, right? The current state that we're on, and that should be all. That should be everything we need to. That should be everything, right? So let's go through our logic. So we initialize max out transitions. We set it equal to -1, because normally the minimum number of outgoing transitions for any state in our automaton is going to be 0, right? So if I say is equal to 0 here, then it's not going to be correct, because by default we might have states that have 0 outgoing transitions, right? But then it's not possible to have a state with a negative number of outgoing transitions. So that is why I initialize this with a negative number, so it's independent of, we won't have any collisions or any conflicts. Okay, so to say. So we loop through all the transitions, and then we get the number of transitions, the number of outgoing transitions of the current state we're on, right? Now, as long as that current count is strictly bigger than the maximum, the max out transitions, we want to update max out transitions and set it equal to the current count, and then we want to point state to the current state. So at the end of, at the end of this particular for loop, we should get we should get the state with the maximum, the first occurrence, that is the first occurrence of, is it the first occurrence? Yeah, I think it's the first occurrence, of the state with the max out transitions. So thank you guys for watching, and I'll see you in the next video.